Alright, let's talk about a big job. I mean, a really big job. Picture this. A massive, gleaming new bridge stretching across a wide river, or maybe a skyscraper so tall it looks like it's trying to tickle the clouds. These things don't just pop up overnight. They're the result of a lot of hard work by a lot of smart people who aren't afraid to get their hands dirty. This is the world of precision engineering, and it's a place where every single detail, no matter how small it seems, matters a whole lot. It's a dance of steel, concrete, and incredible machinery, and it takes a special kind of crew to pull it off without a hitch. I want you to meet the team.
There's Sarah, the lead engineer. She's got blueprints that look more complicated than a map of a secret city, and she knows every inch of this project like the back of her hand.
Then you've got guys like Dave, the crane operator. He's sitting way up high in a little glass box, controlling a giant metal arm that can lift pieces of the structure weighing as much as a dozen elephants.
And on the ground, you have technicians like Maria and Ben, who are constantly moving, checking, and double-checking everything. They're the boots on the ground, making sure the giant's feet are planted firmly.
Their project today is a massive one, lifting and setting the final, central piece of a giant wind turbine. This isn't just a hunk of metal, it's the heart of the machine, the part that holds the enormous blades. It has to be placed perfectly, down to the millimeter. If it's off by just a little bit, the whole thing won't work right, and that's a best-case scenario. A worst-case scenario? Well, we don't like to think about that, which is why this team is so good at what they do. They understand that a big job is really just a million little jobs done right, one after the other. Every person here has a unique and vital part to play.
It's like a symphony orchestra, but instead of violins and trumpets, you've got wrenches, computers, and heavy machinery. Sarah is the conductor, Dave is on the world's biggest cello, and Maria and Ben are making sure every note is perfectly in tune.
They know that they can't build this incredible machine alone. They have to rely on each other, trust each other, and work together as one single unit. This isn't just a job, it's a mission. And today, their mission is to put a very big, very heavy piece of a puzzle exactly where it belongs. So you've got this crew of experts, right? Each one is a pro at their specific task. But here's a little secret I've learned from watching people do the dirtiest, toughest, and most complicated jobs out there. Being an expert isn't enough. You can have the best crane operator in the world, and the smartest engineer on the planet, but if they don't talk to each other, you've got nothing but a recipe for disaster. Communication is the grease that keeps the gears of a big project from grinding to a halt. It's the invisible force that holds the entire operation together.
Imagine Dave, way up in his crane cab. He can see the big picture, the whole site laid out below him like a toy set. But he can't see the tiny alignment bolt that Maria is trying to guide into place on the ground.
And Maria, with her eyes on that bolt, can't see the gust of wind that's starting to push against the massive turbine piece dangling from Dave's crane. They exist in two different worlds, but their jobs are completely connected.
The only thing that bridges that gap between the sky and the ground is the crackle of a voice over the radio, sharing information clearly and quickly.
This is why their communication has to be crystal clear. There's no room for I think, or maybe. They use specific language, repeating commands back to confirm they were heard correctly.
Sarah might say, Dave, we need to come down 2 inches. I repeat, down 2 inches. And Dave will respond, copy that, Sarah. Coming down 2 inches. It might sound robotic or repetitive, but that repetition is a safety net. It ensures that a misunderstanding, a simple misheard word, doesn't lead to a multi-ton piece of steel swinging into the wrong place at the wrong time.
Every conversation, every hand signal, every crackle over the walkie-talkie is another layer of safety and precision. It's how the team builds a shared understanding of what's happening in real time. They are constantly painting a picture for each other with their words, describing what they see, what they're doing, and what they need. Without this constant flow of information, they'd be working blind. And when you're dealing with machinery that can crush a car without even trying, working blind is the last thing you ever want to do. Teamwork is built on trust, and trust is built on good communication. The sun is barely up, but the team is already gathered, coffee in hand, for the morning huddle. This isn't just a casual chat to start the day. This is the first critical step in a long line of them.
Sarah unrolls the day's blueprints and points to the target. Okay, everyone, she says. This is the lift. The weather forecast says winds will be calm until about noon, so we need to be in position before then.
This meeting is where the plan is laid out, where every person on the crew finds out exactly what their mission is for the next several hours. It's where the symphony conductor gets all her musicians on the same page of music. Each person's role is defined with incredible clarity.
Ben's job today is to be the spotter. He won't be turning any wrenches or pushing any buttons. His only job is to watch. He's looking for anything out of the ordinary. A frayed cable, a person walking where they shouldn't be, a strange wobble in the equipment. He's the designated worrier, and his job is to see the problems before they become emergencies.
His focus allows everyone else to focus on their own specific tasks, knowing that another set of eyes is dedicated to watching their backs and the entire surrounding area.
Meanwhile, Maria is in charge of the sensor array. The base where the turbine piece will be set is covered in tiny electronic monitors. These sensors measure things the human eye can't see, like microscopic shifts in the foundation or the exact levelness of the surface. Her tablet shows a screen full of numbers and graphs. A green line means everything is perfect. If that line starts to turn yellow or, worse, red, it's her job to immediately get on the radio and let the whole team know. She's the team's nerve endings, feeling for tremors and imbalances that could throw the whole operation off.
And then there's Dave, the crane operator, who has already done his pre-flight check on his massive machine. He has walked around it, inspected the hydraulics, checked the fuel, and made sure his controls are responsive. His role is one of immense power, but also requires a delicate touch. He has to translate the team's commands into smooth, steady movements. He is the muscle of the operation, but muscle that must be guided by the brain of the team. The constant stream of information coming from Sarah, Maria, and Ben.
Each person has a zone of responsibility, and they all fit together like a perfect, well-oiled machine. The operation begins. The giant turbine piece, suspended by thick steel cables, slowly lifts off the ground. The low hum of the crane's engine fills the air, a sound of controlled power. But for the team on the ground, the most important sounds are the voices in their earpieces, and the most important sights are the numbers on their screens.
Maria is glued to her tablet, her eyes scanning the data streaming in from the sensors on the foundation. These aren't just random numbers, they are the vital signs of the project. They tell her if the immense weight is being distributed evenly across the concrete base. She watches one number in particular, the level gauge. It currently reads 0.00 degrees. Perfect. But she knows that as the crane swings the massive component into place, the ground will settle ever so slightly under the shifting weight. Her job is to make sure that ever so slightly stays within a very, very tight range. If the tilt goes beyond a fraction of a degree, she has to act. She isn't just watching a screen. She is watching the very stability of the structure. She is the first line of defense against imbalance, the one who will sound the alarm if the giant starts to lean.
Over by the landing zone, Ben, the spotter, uses a different kind of tool, a laser measurement device. He aims a red laser dot at a target on the side of the turbine piece. His device tells him the exact distance, down to the millimeter. He then radios that information up to Dave in the crane. "You're 5 meters out from the anchor points, Dave. Coming in smooth." This constant stream of data allows Dave to build a mental map of the space, to see where the component is in relation to its final destination, even when his own view might be partially blocked. Ben is Dave's eyes on the ground, providing precise measurements that a human eye alone could never guess.
This part of the job is a slow, patient dance. It's not about speed, it's about control. The turbine piece moves at a snail's pace, inch by inch. Every movement is deliberate, guided by the constant feedback loop between the sensors, the spotters, and the operator.
The team is in a state of high alert, a bubble of intense focus. They block out all the other noises of the construction site and listen only to each other and to the story the numbers are telling them. It's a quiet, tense process, where the most important work is done by watching, listening, and waiting for the right moment. Now comes the tricky part. The massive component is hovering just a few feet above its final resting place. From a distance, it looks like it's perfectly aligned, but in precision engineering looks like is a phrase that doesn't exist. It has to be perfect.
This is where our job shifts from watching to doing. We use a combination of high-tech tools and, good old-fashioned muscle to guide the final few inches of the journey.
One technician might be using a hydraulic jack, a small but incredibly strong tool that can push with immense force to nudge one side of the base, just a fraction of an inch.
Sarah is coordinating this delicate dance. She's looking at the data from Maria's sensors and listening to the measurements from Ben's laser.
Okay, team, she says over the radio. The east side is high by a quarter inch. Dave, hold your position steady. Ben, a small nudge on anchor 2.
Ben uses a long pry bar, not with a big heave, but with a gentle, controlled push. It's not about brute force. It's about applying the exact right amount of pressure in the exact right spot.
It's like trying to parallel park a whale, and every little adjustment has to be just right. Hold on, hold on! The level is fluctuating. We've got a pressure spike on the north sensor.
Immediately, everyone stops. Dave holds the crane perfectly still. Ben steps back from his pry bar. An unexpected change in the numbers means something has shifted. It could be nothing, just the structure settling in a new way, but it could be a sign of a problem.
We don't guess, and we don't hope for the best. We stop, analyze the new information, and figure out what it means before we proceed.
Sarah asks Maria to read out the numbers. She cross-references them with the original engineering plans on her own tablet. Okay, Sarah concludes after a moment. The settling is within our acceptable limits, but it's faster than we expected. Let's bring it down slower. Dave, we're going to lower 1 inch per minute. I repeat, 1 inch per minute.
The team has identified a small change, assessed the risk, and adjusted the plan. This is problem solving in real time. It's a constant cycle of action, observation, and adjustment, all happening in a calm, controlled manner, even with tons of steel hanging over their heads. Just as the team gets back into their rhythm, a new challenge appears on the horizon. The wind, which was supposed to stay calm until noon, is picking up early. On the ground, it feels like a pleasant breeze, but hundreds of feet in the air, where the turbine component is hanging, that breeze is a powerful force. The giant piece of metal acts like a huge sail.
Dave feels it first. A slight but firm push against his controls. He immediately gets on the radio. Sarah, I'm feeling the wind up here. The load is starting to swing, just a little.
This is the kind of problem that can derail an entire day's work, or worse. An uncontrolled swing could be catastrophic, but the team doesn't panic. They've planned for this.
Sarah checks her own wind speed monitor. Copy that, Dave. I'm reading gusts up to 15 miles per hour. That's our yellow flag limit.
A yellow flag doesn't mean stop, but it means proceed with extreme caution. The plan has to change again, right now. The slow, steady descent is no longer the safest option. They need to stabilize the load.
The team on the ground springs into action. They have heavy ropes, called taglines, attached to the corners of the turbine piece. Their job is to act as anchors, to manually fight against the push of the wind.
Okay, team, Sarah directs. We need tension on the taglines. East side, pull steady. West side, give it a little slack.
The ground crew becomes a human rudder, working in concert to keep the massive component from twisting. They have to anticipate the gusts, pulling and releasing in a coordinated effort to counteract the force of nature. They are now fighting a battle on two fronts: the precise alignment of the component and the unpredictable power of the wind.
Dave has to use all his skill to gently resist the swing with his crane, while the ground crew uses the taglines to dampen the movement. It's a perfect example of teamwork under pressure.
No single person could solve this problem. It takes the crane operator's skill, the ground crew's strength, and the lead engineer's clear commands all working together.
They are a single focused unit, determined to safely guide their cargo home despite the howling wind. In the world of big jobs, there's a book that's more important than any blueprint or manual. It's the safety rulebook. And it's not just a book that sits on a shelf collecting dust. It's a living, breathing part of every single thing the team does.
Every member of the crew, from Sarah the engineer to the newest person on the team, knows these rules by heart. They wear their hard hats, not because they look good, but because a small bolt dropped from 200 feet can be incredibly dangerous.
They wear steel-toed boots and high-visibility vests for the same reason, to protect themselves. Safety isn't just about personal gear. It's a mindset. It's about creating a predictable environment in a place that can be very unpredictable.
Before the lift even started, the team established a fall zone, a wide area directly underneath the crane's path. This area is marked off with bright red tape, and the rule is simple. Absolutely no one enters this zone while the load is in the air.
Ben, the spotter, has a secondary job of making sure this rule is followed without exception. It's a simple rule, but it's one that saves lives.
Every step of the process has a safety check built into it. When a technician connects a cable, another technician checks their work. When a command is given over the radio, it's repeated back to confirm it was heard correctly.
This is called redundancy, and it's a core principle of safety. It means that if one person makes a mistake, there's a system in place to catch it before it becomes a problem. The team understands that everyone is human and humans can make mistakes, so they build a process that protects them from their own errors.
This might all sound slow and tedious. All these checks and double checks, all these rules and procedures. You might think it gets in the way of getting the job done quickly. But the crew knows better.
They know that an accident will slow the job down a lot more than a safety check ever will. A safe job is an efficient job. By taking the time to do things carefully and by the book, they ensure that everyone gets to go home at the end of the day. And on a job like this, that's the most important goal of all. Safety isn't just part of the job, it is the job. With a final, gentle nudge and a chorus of confirmations over the radio, the moment arrives. The massive turbine component settles perfectly onto its foundation. There's a soft, solid thud as tons of steel meet concrete. The guide bolts slide into their sleeves with a satisfying click that only the ground crew can hear.
I watch my screen as all the numbers flash from yellow back to a steady, solid green. The load is secure. The level is perfect. The tension is gone.
A collective sigh of relief seems to ripple through the team. Dave, from his cab high above, gives a short blast of the crane's horn, a signal of success. On the ground, the team members give each other tired but satisfied nods. They begin the final phase of the job, securing the component, unhooking the cables, and packing away their tools. There's no wild celebration, just the quiet pride of professionals who have completed a difficult task.
We successfully navigated the challenges of weight, wind, and microscopic tolerances. We worked as one, and because of that, this giant piece of the puzzle is now exactly where it needs to be.
As they gather their gear, Sarah walks the perimeter one last time, checking the final connections. She sees the result not just of a day's work, but of months of planning and teamwork.
The success of this lift wasn't due to one person's genius or one person's skill. It was the result of everyone doing their specific job with precision and care.
It was because the sensor expert trusted the crane operator, the spotter trusted the engineer, and everyone trusted the process they had built together. It was communication and collaboration in action.
Working together is what keeps everything running smoothly, but more importantly, it's what keeps everyone safe. By sharing information, watching out for each other, and relying on each other's expertise, they create a system that is stronger and smarter than any single person. They turn a dangerous, complicated job into a controlled, precise operation.
As the sun begins to set, casting a long shadow from the newly placed structure, the team can look up and know they didn't just build a part of a machine today. They proved once again that the most powerful tool on any job site is a team that truly works together.